Life begins at NIIT. That is where I really wanna be. NIIT. I'm future ready.
Greetings, Emmanuel. My name is Matilda Milsado. I'm a digital marketing executive for NIIT Ghana, and I'm glad to host you on our Tech Talk series.
Matilda, it's such a pleasure to be on your Tech Talk series, and I'm told I'm the first person, so
yes,
it's a big pleasure, and then it's an honor as well to be on your series.
So, viewers, we are going to talk about data science today. Mr. Asimadi here is a UK-based data scientist, an avid researcher who has worked on several projects to address the problems in the energy sector, the finance sector, and telecommunications using data science. Like any one of you watching this video, I'm also curious to find out what data science is all about. So first of all, Mr. Asimadi, please tell us what data science is.
So I think the simplest definition of what data science is, and it's what I typically use, is just a science. And it is a science of deriving value from data. So they encompass a couple of techniques that you use to look at data, analyze it. And in the end, I think the most important thing is extracting value from data. Okay, so data exists in its raw form. And in there, when you're able to connect it, when you're able to analyze it in the right way, you can extract value, and then you can take decisions that bring value to your business or your organization. And there are a couple of interesting things that have happened in the sphere of data science that are interesting to the definition. Okay, so if you look at, there was a tweet by George Wills in 2012. It was widely shared. It's a tweet that says that a data scientist is a person who is better at statistics than a software engineer, okay?
Wow.
And is better under software engineering than any statistician. So it's a mix of statistics, software engineering, and there's also the element of you being a curious person or somebody who likes to uncover stuff, even data. Yeah.
Okay, thank you. My next question would be, is there any difference between data mining, data science, and artificial intelligence?
Good. That's an interesting one. So I would like to think of this as, if you want to view it, we can view it as circles on a Venn diagram. Okay. So you have a number of circles. I will take data mining first, because data mining, and in order not to make it look too abstract, you can look at the words in the term data mining. It is data and mining. So you have large amounts of data and you want to mine information from it. Okay, it could be textual data, it could be structured data, which is a table with values in it. It could be more complicated data like videos, audio. There's such large variety of data that we have these days, especially on social media. So it's a couple of techniques that allow you to look at such massive data and still be able to extract meaningful information from it. That is data mining. And data science would be a bigger umbrella. So I would see data science as a superset. So data mining will be a subset of data science. So if you are drawing two circles to represent them, data mining will be inside data science. Okay, so all the techniques that you use in data mining are available to you in data science and more. Okay, so data science, like we said earlier, is just the science of extracting value from data. You could be using machine learning, you could be using graphs, you could be using techniques like SQL, and you have access to programming languages like Python, to some extent Scala, and a lot of us don't like using Java in data science because it is it tends to be quite verbose. Not until version 8. Okay. So that's data science. Then when you look at the field of artificial intelligence, that's quite broad, but it is also encompassing the techniques of making machines intelligent. And the measure for intelligence is almost like human level intelligence. And a number of criteria have come up to use to assess what we mean by a machine is intelligent. One of the earliest approach to examining what we mean by a machine being intelligent is the Turing test. So he comes up with a couple of techniques. In that test, they put a human before a conversation of a sort and try to let the human decipher whether it is having a conversation with a robot or it is having a natural conversation with a human.
Wow, that's
so yeah. So if the robot is able to fool the human into believing that he or she is having a conversation with another human, then we can think of the robot as being intelligent.
Wow.
Okay. So artificial intelligence, and if you put it on still that couple of circles that we have, you remember I'm saying data mining is within data science. Yeah. Artificial intelligence would be some sort of, we just have an overlap on data science. So the techniques, a couple of techniques we have in data science, a couple of techniques we have in artificial intelligence exist in data science. But there are some techniques in artificial intelligence that are not in data science. So we typically, the ones we are familiar with in the field of artificial intelligence is what we call deep learning.
Okay.
And to a large extent, artificial intelligence comprises machine learning. But when people mention artificial intelligence, the first thing that comes to mind is deep learning. So the knowledge of deep learning is within data science, but artificial intelligence is not only deep learning. There are other approaches which we call symbolic reasoning that are less explored, that come under artificial intelligence. And those are not available to the typical data science community. There are people who think that a machine, our current approaches to artificial intelligence is limited, in the sense that when we talk of deep learning, the popular approach, you are giving the computer a lot of data, and then you are asking it to almost come up with a model that can predict the future. They think our human reasoning is much more than that. And that's why they think about the symbolic reasoning approach, that humans, when we are reasoning, we have knowledge. We have a certain knowledge that when I say somebody is 2 years, you can easily come up with all the things around the person. That's knowledge that we have. Yes. And we can use that knowledge to make judgments.
Okay. Right.
The current approach in deep learning fails to capture common sense knowledge.
Okay.
And so we think that there can be symbolic approaches that can overcome the limitations of the existing approaches. That's deep learning, which requires massive amounts of data and is sometimes difficult to, how will I put it? It's sometimes difficult to train on a smaller set of data.
Okay. That is very informative. Thank you. Another thing I want to know is this. Is Africa in exploratory stage when it comes to data? And how do you foresee the future of technology in Africa?
Yeah, so when you look at the model we use to analyze the maturity of any business and the maturity of, so we can think of Africa as an organization and decide to analyze it using that model. That model sort of has 4 pillars,
Okay.
and we can put you on at any point in those 4 pillars. The first pillar is and the model is just a simple analytic spectrum. The first pillar talks about descriptive use of data.
Okay.
The second pillar is diagnostic. The third pillar is predictive.
Okay.
And the fourth pillar is what we call prescriptive. Okay, so if you look at these 4 pillars, and I'll go a bit into detail on what these pillars mean. The descriptive layer just takes data and tells you what is happening in the data.
Okay.
So it describes the data. Okay. And then the diagnostic layer tells you why it happened.
Okay.
So if you take the descriptive layer, for example, those who are just showing you tables of data, those who are showing you a bar chart to show that this is the age distribution of patients in a hospital, those who are showing you body mass index and stuff like that are just describing the shape of your data. Okay, so they fall in the first pillar.
Okay.
Then you have the diagnostic, where you look at why did this happen. So if you are in operations and something fails, you look at the data and try to diagnose the problem. And so when you are able to use data in the diagnostic sense, then your maturity is in the diagnostic pillar.
Okay.
And then we go to the predictive pillar. These are the magicians.
Okay.
They are able to look at the data and tell you what can happen in future.
Wow.
Okay, so we are able to predict that your customer will churn, for example, so that when we are able to do that, before the customer actually churns, we can take measures to prevent them from churning.
Wow.
So that's a typical example of the predictive kind of use case. Then you have the last stage where we talk about prescriptive. That is almost automating the decision. So you look at what is happening and the machine determines your best course of action. There's no human thinking or too much human thinking in that. So the concepts of linear programming are interesting there. They also talk about Monte Carlo, where you can try so many experiments and know that this is the boundary of your problem, and you take decisions within the boundary of that problem. Now, looking at all these steps, I think Africa is in the early stages. So we are predominantly using data in its descriptive sense, and to a large extent in diagnosis. Okay. But there are still exceptional cases where people are doing brilliant stuff with data in Africa. There are cases where, and the use cases that are interesting are there. It's up to us to take advantage of it. There's good use case in agriculture, for example. There's a case where with the Bill Gates Foundation, Bill and Melinda Gates Foundation, where they have tried to predict the disease rust using satellite data.
Okay.
Yeah, so those use cases are interesting and they are in the predictive layer.
Okay.
But majority of our story seems to be in the diagnostic layer, and there are a number of reasons in that. One, we are still maturing, and a lot of the techniques in data science are still being understood and monetized.
Okay.
There is also the element that there's that interesting element of the fact that collecting data is difficult. Okay, so yeah, getting the right data and in this digital form that we can process is not as trivial as it is elsewhere. So the practice suffers from that kind of thing. But it is up to us to understand that data comes in different forms. And the data in Africa is different from the data elsewhere. So how do we use our data with the awareness of the African context? And to tell you the truth, Africa stands to benefit a lot from data science, because data science is all about creating efficiencies, which is something we need. Because when you have limited resources, you want to use it in places that will benefit the most. Okay. And there is also the element that if Africa were to use data in the right way, a lot of the problems we have will be correctly scoped, and we'll think that they are probably trivial. When you see the numbers, you scope your problem so nicely that you think they are trivial and you can deal with it. And you can almost think of it, just to state a last example, how we use data in dealing with COVID-19, for example, which is a scenario that we are all familiar with. Yes. Let's take a case where nobody knows what is happening. We only know that there is an outbreak of a disease. Without the data, the way we will react and behave will be different from how we are behaving now. Okay, so assuming there's no data on COVID-19, we are all going to be panicking. Sure. We will not know where to start from, where to stop, or what to do at all. Okay, but now we have data on COVID-19. At least we get a sense that 80% of people recover from the disease. There is some 5% of people who are likely to be sick, like hospitalized, and might end up dying. Okay, that is a problem well scoped. Okay, and we can now begin to take measures to deal with it nicely. Okay, we can now start thinking that, okay, this 5%, can our hospitals cope with this 5% who require significant attention? Okay. And so we start to think, if we put a lockdown now, we will not get the 5%, all of them coming to the hospital at the same time. And then we start doing interesting things. We start thinking, okay, so can we predict how many people will need hospitalization in 2 weeks? Do we have capacity within 2 weeks when we get 100 people who need hospitalization? Okay. And which areas are likely to be our hotspots? And so when you see the maps, the problem becomes less of a bigger problem. And that is, yeah, those are the benefits of data science. And I think we are fairly at the beginning of it, and there is opportunity for brilliance. Okay. Given the kind of population we have, and when something is novel, the first movers have nice advantages. Yes. So there is that opportunity for brilliance in there. Okay. So I wouldn't want to take much of your time, so we can wrap up after this few questions. Somebody who wants to take up a career in data science, what are some of the job prospects? Oh, okay. Yeah. So that's an interesting one. There, people we've had a lot of sayings that data science is the job of the millennium. I think at the beginning of the millennium, I don't know if is it a century. They mentioned in 2010 there was this statement that is the job of the millennium or something like that. So it's an interesting field. The application of data science cut across many domains. So you don't necessarily just have to be a data scientist. You can be a doctor and be aware of data and be literate in data.
All right.
You can be a journalist and be literate in data. Okay. So I always say that a professional who is literate in data has an advantage over a professional who is not. So what you can do as a doctor with data literacy gives you some kind of a multiplying factor. So that is to say that everybody needs some baseline awareness of data and how to take advantage of data. Okay. And then having said that, if you want to be full-time in this and be kind of advanced or have serious expertise in it, you have to choose the part of the spectrum you want to play in. So if you take the left side being the business aspect of things, and the right side being somebody who is close to systems and understand how systems work in detail, you have different job profiles in between.
Okay.
There are people who are close to the business and they are very close to the business. They have awareness of the business scenarios and are able to use data fairly well.
Okay.
So you have the role of the BI expert, business intelligence expert. They visualize data and do the diagnostic kind of things, descriptive and diagnostic kind of things.
Okay.
You have the analyst in that box as well. So business intelligence, data visualizer, the analyst is also there. So that is one layer of jobs that are interesting.
Okay.
Then when you go further, you have the data scientist, which is also an interesting aspect. They are almost like they are solution oriented. So they are aware of the business, but they are aware of very advanced techniques that can be used in analyzing data. So they sort of look at the business problem and look within their toolbox and say, okay, given this problem, this is the best tool to solve it.
Okay.
So the data scientist is also in there. We have, these days, we have other interesting career roles like people who are machine learning engineers. So they specialize in the different types of machine learning algorithms to predict stuff, to analyze stuff, find pattern in data and stuff like that. There is also still the middle box, which is the most complex box. You have people who are big data engineers. So they specialize in big data. And when we talk about big data, we are talking about data that is large. Sometimes we talk about it in terms of it being complex. Sometimes we talk about it in the sense that it is fast-moving data. So there are big data engineers. They deal with data in distributed systems. So the data is not in one computer, it is spread across different computers. So there is that role of big data engineer. There is also, as you go further, the role that is becoming very popular these days is data engineering. So these are people who put our machine learning model into production. And also make sure that the business people, the data scientists who need data, get the data where they need it. Okay, so they are typically building the ETL pipelines that take data from a certain source and put it in the right place at the right time for those who need it to use it. So that's the typical job profile. So when you are someone who is interested in data science, you choose which profile you are interested in. Okay, so whichever profile you are interested in, you choose that profile, and then you specialize in the profile.
Good.
So there are tutorials online that you can use if you are focused enough.
Okay.
Not all of us are that focused, but you can follow tutorials.
Okay.
You can join communities
Mm-hmm.
like meetup communities,
Yeah.
read Medium posts and stuff like that.
Yeah.
You can join institutions like yours, which is the NIIT,
Mm-hmm.
to get some formal education. And I think the awareness that brick and mortar institutions still have a place is also important. That when the classroom environment is unique in a sense,
Mm-hmm.
that you form connections that benefit you not only at that time but in future as well. Yeah. So it's the, if you can do with the classroom environment, it's okay. If you cannot afford the classroom environment, there are free courses online that you can do. And it's even easier now than ever before to learn. There are a lot of resources on Kaggle and stuff like that that you can use.
Okay. Lastly, is there any age criteria to learn data?
Yes, that's an interesting one. So there was a Kaggle survey.
Okay.
And they analyzed the profile of those who were surveyed.
Mm.
And they were distributed from the 20s into the 40s.
Okay.
Yeah. So that's their age distribution. In my opinion, there shouldn't be an age criteria
Okay.
in pursuing data science. That's the ideal world, but the world is not ideal. So there shouldn't be an age criteria.
Okay.
It's almost like saying, is there an age criteria in when you can become rich? Okay.
Right. Yes.
So Mark Zuckerberg made his billions when he was in his 20s. Buffett, if I remember, was way advanced in age when he became a billionaire. Jeff Bezos, you can talk of our own Dangote. They all made their billions at different ages. Okay, and some, if you put an age criteria, you might write a lot of people off who may be brilliant data scientists or brilliant at analyzing data.
Okay.
I will add that it's just the skills requirements that should be the criteria, not the age. If you are inquisitive enough, if you have the brain power to analyze data, if you have the brain power to program against data, if you have the brain power to use data to benefit the business, you qualify to be in the field.
Okay.
And that is not dependent on age. There is also the element of us, whoever, like wherever you find yourself, as a person, there is if you want to be in the field, because the field is so varied, you can choose the layer of abstraction you want to play in. Okay, so they are data architects.
Yes.
They understand how the different blocks work to put up the whole infrastructure for you. They don't code. They just know that when you put this here and connect it to this, you will get the use case you want to achieve.
Wow.
They work in a very high level of abstraction, so they don't care about too many details.
Okay.
So that might fit somebody's profile. There might be other person who says, oh, I like engineering, I like the complex stuff. And that person can be 55 or 60 and want to be in the details.
Okay.
That should also work well for the person. So everybody who is interested can choose the part they want to play.
Okay.
And there's almost a path for everybody who has the right profile to play in data science.
Okay.
Yeah.
Thank you very much, Mr. Asimadi. It's been nice
Thank
talking
you.
to you.
Yeah.
Hope to have more conversations like this in the future.
Yeah, thank you for having me. It's such a pleasure to share my thoughts with you. I think in future we'll get more time to talk about more details.
Sure.
Yeah, because there's
Okay.
always something to talk about in data science.
Yes. So stay safe
Yeah.
wherever you are.
Thank you very much, and same to you. Enjoy your out of lockdown now. I hear Ghana is out of lockdown, so you should stay safe as well and enjoy it.
Okay, thank you. Viewers, thank you also for watching. If you haven't subscribed yet, please make sure you subscribe for more interesting conversation with experts in the tech industry. You too, stay safe. Oh my God, I think I messed up there.
Yeah, yeah,
Let
that's
me
good.